Have you ever just, picked up a pebble on the beach or looked up at some huge mountain and wondered, what's its story? Because believe it or not, every single rock has been on an absolutely epic journey. We're talking fire, water, and insane amounts of pressure. All right, let's get into it and uncover the secret life of rocks.
So, first things first. We throw these words around all the time, right? Rock, mineral. But what's the actual difference? It's a super fundamental question, and honestly, getting this straight is key to understanding everything else. So let's clear that up right now.
And here you go. It really boils down to this. A mineral is a pure, solid substance. It has a specific, definite chemical recipe, kind of like salt is always sodium chloride. A rock, on the other hand, is more like a geological stew. It's a mix, an aggregate of a bunch of different minerals all mashed together. So rocks are made of minerals, but a mineral is its own pure thing.
Okay, now let's meet the first major player in our story, the fiery originals. These are the primary rocks, the ancestors of pretty much all other rocks on Earth.
The name really says it all. Igneous comes from ignis, which is just Latin for fire, and that's because these rocks are born directly from cooling and hardening molten rock. We call it magma when it's still underground, and then lava once it hits the surface. And because they were the very first rocks to form on our planet, geologists have a cool name for them, primary rocks. They're literally the foundation of everything else.
Now, this might look a little complicated, but it all comes down to one simple idea. Where did the rock cool down? On the left, you've got intrusive rocks, like granite. They form when magma gets trapped inside the crust. It cools super slowly over thousands of years, which lets these big, beautiful crystals grow. But on the right, you have extrusive rocks, like basalt. That's when lava erupts onto the surface and cools really, really fast. The crystals don't have time to grow, so you get these tiny, fine grains instead. So it's all about location, location, location.
Okay, so if igneous rocks are the fiery originals, our next character, sedimentary rock, is kind of like Earth's layered diary. It holds the history of our planet's surface right there in its pages.
Right, so these guys aren't born from fire at all. They're actually made from the broken down bits of everything else. We're talking tiny fragments of other rocks, shells, skeletons, plants, you name it. It all gets washed into rivers, lakes, and oceans. And then, over millions of years, layer after layer builds up, and the incredible weight from above squeezes and cements all those little bits together into solid rock.
And this brings us to their absolute superpower. This is what makes them so special. Because they form in this relatively gentle way at low temperatures and pressures, sedimentary rocks are the only kind that can preserve fossils. The intense heat involved with the other two types? Yeah, that would completely destroy any trace of ancient life.
So how does that even happen? Well, it's an incredible chain of events. First, an animal dies and its soft parts rot away. Then, it has to be buried quickly by mud or silt to protect it. As more and more layers pile on top, the pressure builds. Water seeps down through the layers, and over a long, long time, it replaces the original bone with hardened mineral crystals. It basically turns to stone, and bam, you've got a fossil.
And this process doesn't just make small fossils. It builds entire landscapes. I mean, just look at this picture of the cliffs of Normandy. Those stunning white cliffs, they're made of limestone and chalk, which is really just the gazillions of compacted shells and skeletons of tiny sea creatures from millions of years ago. Mind-blowing, right?
All right, our final character in this rock drama is a true master of disguise, metamorphic rocks. Well, they're like nature's alchemists. They take existing rocks and transform them into something totally new.
The name literally means to change form. See, a metamorphic rock isn't born from fresh magma or new sediment. Nope, it starts its life as a perfectly normal igneous or sedimentary rock, but then it gets buried deep, deep within the earth. And down there, the intense heat and crushing pressure basically cook and squeeze it until it fundamentally changes its entire texture and chemical makeup. And you can see some of these amazing transformations right here. That soft sedimentary limestone, it gets recrystallized into hard, beautiful marble. Porous old sandstone gets fused into incredibly tough quartzite. Even a hard igneous rock like granite gets its minerals all rearranged into those cool-looking bands you see in gneiss. It's a complete makeover, from the inside out.
So, what's the bottom line here? This whole transformation process makes the new rocks much, much harder and more compact than what they started as. But here's the trade-off.
That same intense heat and pressure that forges them also obliterates any fossils that might have been in the original rock. The diary pages, they get completely erased.
So we've met our 3 rock types: the fiery igneous, the layered sedimentary, and the transformed metamorphic. But here's the big secret. This is the aha moment of the whole story. They aren't really 3 separate characters at all.
That's right. They're all just different stages in one of the planet's most epic, most slow-moving cycles. We're talking about the rock cycle.
Look at this. This is the planet's ultimate recycling program. Let's just follow one possible path, okay? Say you start with an igneous rock on the surface. It gets worn down by weather into tiny sediments. Those sediments get buried and squished into sedimentary rock. If that rock gets pushed way down deep, the heat and pressure bake it into a metamorphic rock. And if it goes even deeper, it can melt all the way back into magma, ready to cool into a brand new igneous rock and start the whole journey over again. It's a continuous loop with no real beginning or end.
Now, this is a really cool geological story for sure, but why does it matter to us, like in our daily lives? Well, it turns out this ancient cycle is fundamental to almost everything we do.
I mean, really think about it. The soil we use to grow our food, that comes from weathered rocks. The concrete and asphalt for our roads and buildings, all from rocks. The gold and silver we use for jewelry and electronics, even the coal that has powered so much of our world, it's all found inside specific rock formations. We literally build our civilization out of this stuff.
And get this isn't some new thing. The Earth has been running this incredible recycling program for about 4.5 billion years. It's a timescale that's almost impossible for our brains to really wrap around, but it's happening all around us, right now, just incredibly slowly.
So the next time you see a rock, any rock, just remember its story. It might have been molten magma, then part of a giant mountain, then sand on an ancient beach, then squeezed and cooked deep underground. It has been on a journey for millions, maybe billions of years, and its journey isn't over. So the question is, what do you think it'll become next?